morning students, myself Dr. T. Sudarshan Ramaperumal. Today we are going to see about the error correction and detection. Error correction and detection in network. First we are going to see about the types of errors, then find the detection, how to detect the errors and how to correct our errors. So network must be able to transfer data from one device to another with complete accuracy. Data can be corrupted during transmission. For reliable communications, errors must be detected and corrected. Error detection and corrections are implemented either at the data link layer or in the transport layer of the OSI model. So types of errors. We have single bit errors, multiple bit errors and burst errors. So only one bit will be corrupted during the transmission time. We say that it's a single bit error, and single bit errors are the least likely type of errors in serial data transmission because the noise must have a very short duration, which is very rare. However, this kind of errors can be happen in parallel transmission. Example, if the data is sent at 1 Mbps, then each bit at least only 1 by 1 lakh seconds or 1 microseconds. Burst errors. In burst errors, more than one number of bits will be changed at the time of duration. 2 bits errors means only 2 bits will be changing or corrupted during the transmission time. So in terms of burst errors means that 2 or more bits in the data units can change from 1 to 0 or from 0 to 1. Burst errors does not necessarily mean that the errors occurs in consecutive bits. The length of the burst is measured from the first corrupted bit to the last corrupted bit. Some bits in between may not have been corrupted. Burst errors most likely to happen in serial transmission, since the duration of the noise is normally longer than the duration of the bit. The number of bits affected depends on the data rate and duration of the noise. These are some of the examples how the data rate will be calculated. Error detection. Error detection means to decide whether the receiving data is corrupt or not without having a copy of the original message. Error detection uses the concept of redundancy, which means adding extra bits of detecting errors at the destination. So first method is the redundancy method. For if we want to, 4 types of redundancy checks are in the data communication. First one is VRC, LRC, CRC and checksum. In our servers we have only CRC and checksum. So we are going to first see about the CRC, cycle redundancy check. In cycle redundancy check, the original data is divided by the divisor and the remainder will be added back to the original data, and the same data will be transmitted over the transmission media, and the particular data will be received at the receiver side, and the particular data will be once again divided with the same divisor. If we get 0 at our remainder, then the data will be accepted. Non-zero will be we reject the particular data. Given a k bit frame or message, the transmit generate a n bit sequence known as frame check sequence, so that resulting frame consisting of k plus n bits is exactly divisible by some predetermined number. The receiver then divides the incoming frame by the same number, and if there is not remainders, assume that there was no errors. So this is a simple example for how the data will be divided by the divisor, and the remainder will be added with our original data. This is how the data will be generated with the given polynomial. And then checksum. In checksum we are going to calculate the checksum for each sections, and the final checksum value will be added back to the original data. And once again we calculate the checksum in the receiver side. If all the bits of the checksums will be 1, then the data will be accepted, otherwise the data is rejected. The unit is divided into k sections, each of n bit. All sections are added together using 1's complement to get sum. The sum is complemented and becomes the checksum. The checksum is sent to this data. At the receiver, the unit is once again divided to the k sections, each of n bits. All sections are added together using 1's complement to get sum. The sum is complemented if the result is 0. The data are accepted, otherwise they are rejected. Error correction. It can be handled in 2 ways. Receiver can have the sender transmit the entire data unit. The receiver can use an error correcting code, which automatically corrects certain errors. Single bit errors. To correct an error, the receiver reverse the value of the altered bit. To do so, it must know which bit will be errors.